Now we'd like to show you how to define transport maps. Transport maps allow us to map the left-hand side to the right-hand side based on the following. The left-hand side can contain a user at a given domain, such as linuxcbt.external, a domain that we'll be using. It may also contain a domain. It may also contain a subdomain indicated using .domain, such as .linuxcbt.external, which includes all of the subdomains beneath the second level domain linuxcbt.external, or whatever domain you specify. So on the left-hand side, we can define what postfix is to match, and the right side equate will be the transport that it's to use to deliver messages that match the left-hand side. On the right-hand side, we can specify a syntax such as the following: transport followed by the next hop. The next hop usually is a system that's specified to handle the routing of messages. Now what this allows us to do is to bypass using MX lookups, for example, or any DNS queries, so that we can direct messages exactly where we'd like to send them. In addition, you may want to distribute messages for certain domains to certain machines. The transport map allows you to do so, even for a specific user. Let's say, for example, that the linuxcbt SUSEServe1 box is the mail gateway or the mail hub for all inbound messages off the internet into your corporate environment, and you'd like to route messages based on user at domain, a domain, and any subdomains, any number of subdomains, and have them directed to the machines that you'd like. For example, messages destined to the user root at linuxcbt.external could be redirected using a transport map to a given system rather than to another mail hub. Let's take a look at how we're going to set up the transport mechanism to handle the routing of messages. Again, this allows us to bypass having to set up DNS zones. Currently, we have DNS zones set up for linuxcbt.internal as well as linuxcbt.external. So if we'd like, it's easy to query the MX records for either. Simply execute a dig linuxcbt.internal followed by MX, and this returns the mail exchanger for the linuxcbt.internal domain. Perform a similar query for linuxcbt.external, and it returns the mail exchanger for linuxcbt.external. But for other domains that we'd like to manage, they simply don't exist, such as Linux computer-based training.internal as well as Linux computer-based training.external. Transport maps allow us to make this happen. Now, transport maps are based on the default types of maps that we've defined all along, including the hash type maps, and we simply need to specify a directive within the main.cf to go out and fetch the values that are stored in the map. You can echo what the system currently recognizes as maps or transport maps using the postconf command followed by grep, and simply search for transport underscore maps. Normally, in its undefined state, transport underscore maps is equal to blank or undefined, which means that postfix will deliver messages based on its default transport maps. Its default transport maps are usually to send messages using either SMTP or deliver it locally. You can also determine the transports that are supported by your postfix implementation by examining them in the master.cf file. By examining the master.cf file, which is located in etc postfix, on the left-hand side, you'll actually see the name of the transport. SMTP is the name of a given transport. And there are other types of transports as well, including local, as well as the error transport, which we can use in certain conditions. You may want to use the error transport in a condition where you've transitioned from one domain name to another, and you'd like to return error messages rather than gracefully handling the transition for incoming messages. Great. So what we'd like to do is set up two extra domains that are to be relayed, or we've already set up the domains that are going to be relayed through our system. In fact, if we execute postconf and we'll grep relay underscore, which we're really looking for relay underscore domains. We'll search through the list of domains. We're handling anything destined to my destination, as well as we're looking up values from a hash, which is stored in the relay underscore domains file, which we can expose by simply catting the contents of relay underscore domains. So we're handling messages destined to linuxcbt.external. We're relaying, we're relaying to Linux computer-based training.internal as well as external. This is what we did in the last section, and we found it to be a great segue into the definition of the transport maps. So in our maps, we'd like to include these items. Now the maps are two-dimensional. They contain two columns. On the left-hand side, it's what to match, which is specified using domain, subdomain, or user at domain. And on the right, it's the transport : next hop. So let's just simply copy these two entries that you see here. If we'd like, we can copy all the entries, including linuxcbt.external. Let's take them all. And we'll nano a file called transport. It currently doesn't exist, although if you've installed SUSE Enterprise Linux with the default implementation of postfix, it may exist on your system. So again, on the right-hand side, we'll define the transport : next hop. Now the transport is typically SMTP, so if you're going to relay messages using standard SMTP, specify SMTP as your transport : followed by the next hop. Now if you'd like to be explicit, simply specify the name of the machine. Now the machine doesn't have to be in the domain. It doesn't have to have a name in the domain, such as linuxcbt.external or Linux computer-based training.internal and so on. So SMTP : and the next hop, or the recipient, the receiving machine that we'll specify here, is called linuxcbt work1.linuxcbt.internal. This works out well because we're currently logged on to linuxcbt SUSE serve1, so we're going to pretend that SUSE serve1 is the mail hub, the gateway that's connected to the internet receiving messages, but deciding based on the rules that are defined in the transport table to route messages to a subsequent system. Now another note, if you'd like to avoid any further MX lookups, which may fail if the zones are not set up. In the case of linuxcbt external, it is set up, but for the two following domains, they're not. You should enclose your next hop in between brackets. By doing so, you indicate to postfix to not perform an MX lookup. And that can save time and aggravation from troubleshooting failed deliveries. Let's perform a similar function or specify a similar entry for the subsequent domains. Again, the transport is SMTP, and if you'd like to use a different transport such as UUCP or local or error, then just specify them or consult your master.cf file. SMTP : followed by the two brackets, and in between we'll specify linuxcbt work1.linuxcbt.internal. And finally, we'll do so for Linux computer-based training.external, linuxcbt work1.linuxcbt.internal. You could also specify in between the brackets an IP address. That's optional, but a name usually works out better because of, or from a redundancy perspective, or from the perspective of change, since IP addresses are subject to change, whereas names tend to stay or remain the same. Great. Now that this is in place, we need to, of course, use postmap to generate a database format of the transport file. So let's use postmap to generate the transport database. Now, when we sort, we have a new file called transport.db, but we're not done on the mail hub side yet. Again, pretend that this is your mail hub that's located in your corporate DMZ, demilitarized zone. We need to instruct this particular mail hub, or our pretend mail hub, to use the transport maps that we've just defined. So let's modify the main.cf file. We'll navigate towards the end of the document. We'll use Control-V in Nano. And we'll just add a section here which indicates added transport map support. And we'll specify a date as well. And below, we'll simply specify the directive, which is transport underscore maps is equal to, and of course, it's going to follow the format type, which is usually dbm, hash, and so on, or db, followed by the full path, which is preferable, and the name of the file. So type and file. So let's go with hash, because we've compiled in Berkeley DB hash support, but we also have support for btree, followed by etc postfix, followed by the transport DB file that we just generated. Now we have transport underscore map support in our main.cf file. All that's left to do, or remains to be done, is to reload postfix on the mail hub. Simply execute a postfix, reload, and now we have transport underscore maps support built in. A postconf grep transport underscore maps will return the new directive, or the new value for the directive. It's no longer undefined. Postfix now knows to consult this particular hash. Now, items that are in the hash will actually, or items that are cross-referenced by the transport underscore maps directive, will override other transport underscore maps directives within the main.cf files. So you can use the transport underscore maps directive as a central place for storing all of the domains, all of the relationships, all of the routing, for all of the domains that you handle, both local and remote. Now that this is in place, the next thing we need to do is provide support on the server, or on the other server side, the inside, or what we're pretending to be the inside mail server, which is Linux CBT Work 1. Again, we're pretending that Linux CBT SUSE Serve 1 is the enterprise box, which is a gateway connected to the internet, which is our first tier screening server, which forwards messages into Linux CBT Work 1. Now, throughout our studies across products, SendMail, QMail, and so on, we change the roles of the systems according to the scenario that we're caught in. But again, whether it's the enterprise server or the professional product, they're both running postfix version 2.1.5, so we can treat them in either way, since they're able to communicate with each other. So next, we finish up this configuration and we test the messages being forwarded to our new transport recipient.